So if you were absent Friday or if you were here Friday, regardless, you're always responsible for all the work. I do not spend hours planning and putting things in the Schoology for you to ask me what we did or for you to not know what we did. It's in there, I promise. I think of everything. I think of what if they don't know how to do the assignment? I provide a video lesson. So your assignment Friday was to watch the video, take notes on your own paper because I don't have note sheets for you. At least I didn't last week. I don't have note sheets for you for that lesson. Take the notes on your own paper, upload that to Schoology. That's how I know you did what I asked you while the sub was here. And then the assignment is the puzzle piece. So if you didn't get that done, you can still turn it in for full points up until when? Unit test. Up until the unit test. So I get it. Life is busy. I get it. When you see that there's a sub, you think, okay, great. I don't have to do anything right now. It's up to you. It's your grade. If you're still responsible for it, if you care enough, you'll turn it in by the unit test or just not at all. All right, we are moving on to lesson 10 today, which is to calculate average rates of change for exponential functions. You'll know that you're successful if you can calculate the average rate of change of a function over a specified period of time, and how the average rate of change of an exponential function differs from that of a linear function. A lot of this you should know how to do because we covered it in semester 1. So like average rate of change, what's the formula for average rate of change? So y1 minus y2 over, yeah? Good. Normally I write it the other way around. I write it as y2 minus y1 over x2 minus x1. It doesn't really matter. As long as the parts from the same coordinate are like on top of each other. So like these would be on top of each other, and then my x2, y2 would be on top of each other. No, I can show you parents, but yeah, so as long as the ones from the same coordinate are on top of each other in the fraction, then good job. You know how to calculate average rate of change. So you'll see that over and over again. I warned you last semester that's how it would be, so just remember it now from now on. Another part of this, how the average rate of change of an exponential function differs from that of a linear function. First of all, what do the graphs for exponential functions look like? Okay, so if I copy that, something like that. What's another way it could look like? Okay, good. So your exponential functions look either like this if it's growing, or something like this if it's decaying. So starting out around the same amount, and then either increasing at a really fast rate or decreasing at a really fast rate. How does that compare to your linear functions? What do linear functions look like? Straight line. Positive would look like that. Negative would look like that. Now, one of the goals, let's kind of just answer that now, is how it differs from a linear function, the average rate of change. So on a linear function, is the average rate of change contained throughout? Yes, no. Yep. And why is that? Because it is a straight line. That's basically it. Y equals mx plus b. M would be your rate of change. M would be your slope. Adding or subtracting the same amount each time means that the average rate of change will be the same whether you're looking from here to here or from like here to here. It will end up being the same value throughout. Is that the same for exponential functions? No, because if I look from, say, here to here, it doesn't really look like it's changing much, does it? But if instead I look from here to here, it does look like it's changing. So it changes by different amounts depending on what two intervals you look at. So that kind of answers that, which you may have already noticed, but now we'll actually attach the math to it. So I'm recording right now. I'll link it in the slides. Your practice will be the blue puzzle piece titled Lesson 10. It has been available since last week, so hopefully some kids are taking advantage of, you know, working ahead. So that's great. Plus, it makes it easier for when we get to the lesson in class, you already know like what to ask. And then our next quiz will be the mid-unit 5 quiz. Whenever we finish lesson 13, we will take that quiz. And it's over really everything thus far. So, questions? All right, one thing that I will be emailing you and all your parents today is about tutoring. So originally at the start of the semester, I said that tutoring would be starting on the 25th. Well, unfortunately, I have a meeting across town that I have to go to. Normally, I like rearrange my schedule to accommodate tutoring, but there's no other day for this meeting. So that's where I'll be Wednesday. So to make up for that, I will offer tutoring this Friday instead. But then after that, it'll just be strictly Wednesdays. So if you ever need to like see what the tutoring schedule is, if there's any changes or something, it's always on this whiteboard that I'm pointing out. Okay, so I'll email your parents so that you know. Questions on that? All right, but even with that, like if you're really stressing about grades, like you're planning to come this Wednesday to retake, there is stuff you can do from home that you don't necessarily need to come to tutoring for. Like you can test correct your quizzes from home. Usually after like 99% of people have taken the quiz, I open it for viewing and you can see which ones you got wrong, correct them on a piece of paper. And then I'll give you half credit back, but usually that's enough to get you to passing, especially at the beginning of the semester. And then when tutoring happens, you can come back and take it for full credit. But one thing I will tell you, students sometimes will send me their test corrections looking something like this. Right, like just answers, no work. You don't get points back for that. All right, for all I know, you got the answer from a friend. The reason I require you to show work is because I want to know, like, now you know how to get to that problem. Even if you did get help from a friend, I want to know that you now know how to get to that answer. And that's why I give you half credit back, because I know you could ask your parent, ask your friend, look it up online, but you have to show work. Or if you can't show work, provide an explanation to get those points back. Those are assessment points. Like that shouldn't be allowed, but I allow. So questions on that? Okay. All right. Finally, moving on to the real lesson. So here's the warm up. It is printed on your paper. So yeah, I can start printing things for you again. So let P be the function that gives the cost P of T in dollars of producing 1 watt of solar energy T years after 1977. Here's a table showing the values of P from 1977 to 1987. Which expression best represents the average rate of change in solar costs between 1977 and 1987? So look at it. Think about it. I'm going to pull the class in a little bit. And I want everyone to participate. Because what happens if you leave a question blank on the test? It's a 0. But if you guess out of 4 options, because it says which expression best represents it, so you just pick one. If you guess, you have a 25% chance of picking the right answer. And if you can eliminate any of the other answers, well, then your chance of picking the right one gets higher. So look at it, decide. Maybe like 1 minute. I'm just going to take a poll. Meaning you vote for what you think is the right answer. So raise your hand if you think 1 is the answer that best represents average rate of change in solar costs. All right, raise your hand if you think number 2 best represents it. Raise your hand if you think number 3 best represents it. Okay, I counted 9. They're like the tiniest hand raises. And then raise your hand if you think number 4. So again, only those 9 people, I mean, I'm not saying it's right yet, but only those 9 people have a chance of even getting some credit because the rest of you didn't participate. So pick one, even if you have no clue which one looks the best. Now no one picked 1. Why would it not be 1? So what do we call it when it looks like this? Is this P times 10 or what's going on here? So this little chunk of information right here says that when I plug in 10, that output is P of 10. So it would be 4.51 minus whatever P of 0 is, which is what, 80? Does that look like an average rate of change? What's missing from it? I mean, we do subtract an average rate of change, don't we? What is the formula for average rate of change? So if you don't have that memorized yet, then write it down. Because I don't provide that. That is like a formula you use all the time in math from now on. And yeah, you could do y1 minus y2 over x1 minus x2, same difference. All right, so it's not 1 because we're missing the dividing by the inputs part. Why is it not 2? It looks weird because it doesn't really have much of anything. That one probably might have been the first one you could eliminate. That one would just say this is my answer, and that's just not an average of anything. 3, what does that look like to you? Does it look like the formula that we wrote down? Yeah. So it probably is. If you look at it more closely, it is my change in y's, because remember, outputs are also your y's, divided by my change in x's, which time is usually my x anyway, so that makes perfect sense. Yes, 3 is the answer. 4 doesn't make any sense, because that's a y divided by a y. All right, question. So average rate of change is this formula, or I also sometimes use change in y divided by change in x. Again, that's the same difference. Question. So then, yeah, definitely when it says which expression, only pick one. It's not telling you to calculate anything, just pick one of the answers. Eliminate some bad answers if you can. But what test strategy have you heard before that, like, if you have no clue, absolutely no clue what to do, what answer should you probably pick? B or C? I've always been told when in doubt, choose C. Yes, and I feel like that's true most of the time. Whenever people make tests, for some reason, they gravitate toward either B or C, those columns. But that's just something I've been told, and that's what I've kind of seen over my years. So no clue at all, can't eliminate any of them because you have no clue. Pick C. Odds are it might be the right answer. Not all the time, but just statistically. All right, so moving on to the next activity. Here is a table and graph that show the number of coffee shops worldwide that a company had in its first 10 years between 1987 and 1997. The growth in the number of stores was roughly exponential. So roughly that curved line. It might not be perfectly that curved line, but roughly exponential. This is also on the next page too. So first thing you'll do within your groups, most of you have at least 3 people, find the average rate of change for each period of time and show your reasoning, meaning showing your work would be fine enough. So there's 3 different problems here. You can split it up, divide and conquer. Since it's 3 problems, I'll give you 3 minutes. So can you calculate average rate of change for a given period of time? Try that. Okay. Let's see. Table 3, did we get an answer for A? Did we? We just need more time. Or what is that? Oh, you still have notes. We did a few examples earlier. All right, I'll come back to you, you guys. You guys are in charge of A. Table 5, do we have the answer for B? I think I might hear you, let me check. 256, there's 255 over 6. Which class can someone throw that in their calculator and tell me what exactly that is? 42.5 as the final answer. Anyone get something different than that? All right, that is correct. So if you did not get that, pay attention to these instructions. I'll do the work down here because there's a little crammed in there. But here's the average rate of change formula that I told you to write down. So when you see that on your test, start by writing down that equation. And then look at where it wants you to look at. It wants you to find the average rate of change between these 2 years. If I'm using this formula, make sure you know what coordinates you're dealing with. So like, what's the coordinate for 1987? The XY. What's the input at that year? And you have 2 visual representations. What is the input? That is not the input. 17 is the output. The input is 1987. Good. So you have 2 visualizations. You could use the graph, and sometimes you have to use the graph because they don't give you a table. But if they give you a table, these are the best because they tell you exactly what the number is for the X and the Y. Year or time is usually your X. The other thing is usually your Y. The dependent variable is the Y. If I was looking on my graph, that would be this dot. Is it really clear to see what that Y value is? No. No. So that's why I say if you have a choice between a table and a graph, use the table. So that's my coordinate. I'm gonna make it X1, Y1 just for fun. The other coordinate for the 1993, what's the input at 1993? 1993, that's my year. And what's the output? 272 is correct. We're looking at part B right now. So, yeah, figure out what your X1, Y1 would be. This one would be my X2, Y2 then. And plug it into this equation. So when it's plugged in, the way I labeled it, it would be 272 minus 17 over 1993 minus 1987. Granted, you could have also put, and I forget what the numbers were, but like how this graph has it as years since 1987, you could have put on the bottom 6 minus 0 for years since 1987, and you would still get 6 on the bottom regardless. So that's why I also accepted the years. All right, now is 272 minus 17, 255. Yeah, that's how they got that. And then 1993 minus 1987, is that 6? So then divide those out. This is my average rate of change, so 42.5 for B. And then you do the same for the rest of them. Only thing that changes each time is the coordinates. So it happens to be 1987 for all of them. You just have to figure out the other one. Also, real quick, notice each paired value, like this paired coordinate, would be on top of each other in the fraction. If they're diagonal, then there's something wrong. You plugged it in wrong. So just take note of that. Same with how these two pair together. They should be on top of each other in the fraction. So even if I wrote it like this, as 17 minus 272 over 1987 minus 1993, I should still get the same answer because these have to stay together on top of each other, and then these have to. You would get negative 255 over negative 6, which still gives you a positive 42.5. So questions on B? All right then, table 3, did we figure out A? 22.3 is correct. And then table 6, what is the answer for C? 139.5. Anyone disagree with A or B? Do we need to see the work for A or C? If so, which one? You want to see it for A? Okay. So then A, that coordinate, the first one is still 1987, 17, right? So that's same year as before. What will the second coordinate be? So let me pick a different color. We'll do orange. All right, so 1990, that would be 1990 for the input, right? What for the output? 84. I'll keep this one as X1, Y1 since that's what I had already. I'll make the other one X2, Y2. So we're looking at the one in orange. And then plug it into your average rate of change formula. So it would look something like this. 84, because remember we're looking at these two now, minus 17 over 1990 minus 1987. What's 84 minus 17? 67, thank you. What's 1990 minus 1987? 3. Divide those out. You get 22.3 repeating. Round it however they tell you. I just rounded it to the first. So we'll continue tomorrow. Don't lose your paper.